All right, this is 6.5, Calc 2, arc length. Okay, so we're finding the surface area of a solid revolution. This whole thing, it's kind of complicated, but if you look at the formula, it makes a lot of sense. Now, the surface area, okay, surface area S of a frustum, okay, a right circular cone, okay, equals the product of 2 pi times average radius of the frustum of the slant height of this. So it's radius 1 and radius 2, okay? So L would be my length from here to here, okay? And how do we get the arc length? Oh crap, there it is. Arc length, right?
Yeah.
L would be the arc length. Yes? L would be the arc length from whatever we hit here to here, right? And so it's going to be radius 1 plus radius 2, right? It's basically like a trapezoid, but we rotate the trapezoid. Yeah? Okay. So over 2 times 2 pi. So all this comes together, you know, pretty good. But then going back, the surface area goes along with this, depending on the direction. This is the dy. So that means this one's wrapping around the y-axis for this. So for this, the arc length on this one, S, arc length on this one right here, it's from C to D, you know, times the derivative squared of this. So if we're looking at this, this would turn into the integration, right? Integration from A to B, those are my endpoints, right?
Yeah.
Of the function times, this is the arc length right here. Arc length. Yes, so that's my L.
Yeah, that is.
Okay, so is that making a little bit sense? We have the arc length right here. This is the L. It's the integration from A to B times 2 pi.
Yeah, and then the f of x, what would be your radius, or?
Yes, f of x would be
Like
the
as if you're
the function from right here. So it's going to be whatever the height is of that as we're rotating it.
Okay.
And this one is around the x-axis here.
Cool.
Okay, so therefore it should have a dx, right?
Yeah.
Okay, good. So this formula, it's really important. It is on the AP exam. You really, like, they don't give you formulas. So these are things that you're going to have to try and memorize. Now, have you guys looked at the Quizlet app? I sent it out. Quizlet, this is helpful, especially for your derivatives and integrations. Okay, couple things. So, like, what's the integration of secant x?
CDT.
Try it again.
Oh, keep praying. L in absolute value secant plus tangent x. Plus
Thank you. Plus c.
We did
Oh,
I know, we did this
I thought
recently.
it was wrong all the way.
Okay, we did it recently. I just want to make sure you guys are keeping up with this because these are things that you should know and not have to try to work out. You should know these ones. Like, what's the derivative of tangent? Derivative of tangent.
She got it.
I didn't hear it.
Secant squared.
Yeah. So these are things that you guys have to try and keep on. All right, so find the surface area S of a solid generated by revolving the region bounded by this graph, the x-axis, x equals 1 and x equals 4 about the x-axis. So let's take a little sketch right here. So it is bounded, square root of x, looks something like this, right? Yes?
Yes.
Okay, something like this. The x-axis, so here's my x-axis, okay? There we go. And we have 1. So here's 1, and it goes to 4. And it should be 2, right? Yeah, basically. So it's from here to here. So I have my function, So I need the derivative also, right? For my arc length, I need the derivative of the function. So I know that y prime is going to be 1/2 x to the
Negative.
-1/2. Or I could say y prime is equal to 1/2x to the 1/2, right? Yes? Good. Okay. So let's go ahead. Let's work it and plug in what do we have. So it's going to be s is equal to 2 pi from a to b. What's my a to b?
1 to 4.
2 pi.
1 to 4.
And then f of x.
F of x. So it's going to be
Square root of x.
x to the 1/2, right?
Yeah.
Times, and that's going to give me,
1 plus the absolute value.
right?
Oh,
Nah,
wait, that's a bracket. Oh,
yeah,
it's
so-
tiny font. I'm sorry.
yeah. Okay, so it's plus the derivative squared, right?
Yes.
Okay, so it's going to be, what did we say? Okay, so it's going to be 1/2x 1/2 squared, right?
Yeah.
And this is my dx. Okay, so let's go through, and I'm going to fill in my sketches here. So for this, I'm basically gonna wait till my board decides to start working again. There we go. Alright, so let's see. I have right here. So it's going to revolve like this. And then same thing here. Right here. So as this revolves, something like that, I get the revolution of this. So I get some type of, looks kind of like a bell, but it's not. So anyway. So as we're plugging in and do this, so I think I need another sheet right here. Yeah. So it's going to be so 1/2x. All right. So let's go ahead and try and clean up the inside before we actually try and set up a U sub, because that's probably going to be the biggest issue I'm going to have. So let's see. When I square 1, it's going to give me 1. When I square the 2 times x to the 1/2, it's going to give me
4x. To
just
the,
to the 1, right?
yeah, to the
So it's going to be 4x. So this is going to be yes,
Yeah.
x 1/2. Okay, so let's go ahead and take a look at what we have right here. And again, 1 to 4 to pi. So because that radical I have there, I'm going to have to U sub, right? So common denominator this, so it would end up becoming 4x plus 1/4x, right? Okay, so that would be that there. That doesn't really help me very much. So, is there an identity I could try and get out of this? Because that radical and the 1 plus something inside that radical, is that going to help me out?
almost.
Is there
It's almost like a trig inverse.
is there a trig one for it? Maybe.
I don't know, Jimmy knows.
Let's see.
Or doesn't.
Maybe. Possibly.
It's
No? Maybe not. All right, let's try U sub the whole thing then.
You don't know that.
You said.
Okay, then U sub the whole thing. So if we go U is equal to 1 plus 1 over 4x, right? So my du would equal to negative, right?
And move that over.
Okay, so that would give me, let me see, that would give me,
4x squared du.
so negative 4x squared du is equal to dx. So let's take a look, and since I have right here, I could still try to actually get this piece out, right?
Yeah.
Okay, so I know that x, so it's going to be u equals 1 plus 1 over 4x. U, come on, u minus 1 equals 1 over 4x. So it's going to multiply over here, so 4, okay, so it is, come on, work. All right, so it's going to be 4, actually, just multiply by the x. I'm going to save some time on that. Multiply the x, so it's going to be x times u minus 1 equals 1 over 4. Divided by this, so it's going to give me x is equal to 1 over 4 u minus 1. So I could replace the x, right? Possibly. Okay, I could replace the x, and I could actually try to replace everything that I can. So if I'm replacing an x squared, okay, an x squared, I could actually try and get rid of this. So let's see, it's going to give me 2 pi from 1 to 4, but I'm going to change my bounds here in a minute. So x is going to give me
1 over 4 times, or 1 over 4u minus 4.
1 over,
Wait, to the 1/2.
4, let me see, u minus 1, 1/2, and this would be times u to the 1/2, and it's not du yet, okay, for the du, so I have to replace all of this right here, right?
Yeah.
So did that one work out very well?
No, that's all.
That one didn't work out very well, did it? So there's got to be another way to try to actually isolate that.
Must be that trig.
So is there a trig one? Is there, because when I plug in this, I'm going to have my 4x squared. I'm going to have a whole bunch of crap in here, right?
Is there arctan?
Is there something like that in there? What is an arctan?
What is arctan?
Is it the square root of 1 plus x squared?
And it kind of looks like that from the first one.
Yeah.
So then it'd be
Are we
tan.
just saying yes or tan?
What about
Arctan.
Yes.
integration arctan? Isn't that 1 over 1 plus x squared?
I'm actually pulling it up right here because I do not want to screw this one up.
I have my flashcard.
You got your flashcards?
I just pulled it out like 5 minutes ago.
No, I need.
No, I don't have it. Yeah, they're all one.
So, this one didn't work out very well, did it? Okay, so let's go back. Let's back up. The sub didn't work very good. Okay. With U sub, it has to work nice and pretty. It's kind of hard to force it, otherwise you'll mess it up and make it actually uglier. And let's still got my dx right there that I erased. Okay, so serious question. Isn't this what happens when you multiply a square root, like let's say like a square root of 2 times the square root of 5? Right? Yes?
Yeah.
Using numbers, that makes sense, right? But now, if I look at this right here, what else could I do with this? I could put it together, right? So I'm going to multiply this. So I'm going to change this up. So this is going to be, you see, x parentheses 1 plus 1 over 4x, right? To the 1/2.
Yes.
Yes? So does that make a little bit more sense? So 1/2 and that radical, that's actually kind of messing it up, right? So let's go ahead and do my distribution. So I get x plus 1 over 4, common denominator. Common denominator, so it'd be 4x plus 1 all over 4, right? And this is to the 1/2. Yes?
Yeah.
Okay, good. So, I'm gonna, dang it. Insert page after. So now I still have my 2 pi 1 to 4, and now this whole thing turned into 4x plus 1 over 4 to the 1/2 dx, right? What can I do with that 4 on the bottom? What can I do with the 4? Yes, you can, but what does it go? What is it out there as?
Yeah.
What does it go out there as? It'd be a 2, right? Because I could separate this right here. So this is over 4, so the square root of 4 is 2, right? So it's 1 over 2. Yes? And what's going to happen to the 2 that's out here with that 1 over 2? Goes away. So now I'm going to have pi 1 to 4 of 4x plus 1 to the 1/2 dx. Now this is actually a little bit more manageable, right? Because that other one didn't work out. We didn't look like we had some good things that would actually come about with that. Because my 2 radicals kind of made a mess, right? So the u sub didn't work right away, so we're like, all right, so now we have to try and change it to make the u sub look a little bit better. Now, can I u sub this? Say yes.
Yes.
Okay, let's u sub this. So u is equal to 4x plus 1 d. So, it's even worse. Come on. du is equal to, that one's going to give me 4 dx, right? So, 1/4 du is equal to dx. There we go. So this is u to the 1/2, right? And then when I put in the du, it's over 4, right? My pen's running out of ink.
Yeah.
Okay, so let's change our bounds. Come on, you can do it. You can do it. Let's go. All right, so let's see. 1. What is my new u bound going to be for 1? Plug it in. So it's going to be 1 times 4 is?
It's
4
Yeah.
Why doesn't
my pen's run out of ink, I guess.
Wait, wouldn't it be like, yeah. Wouldn't it be 5?
Yeah, I was trying to talk my way through it. Anyway, so 4 times 1 is 4, plus 1 is 5, right?
Yeah.
I got sidetracked because my nothing wants to work. I guess my pen did run out of ink. So this is 5. And the other one is going to be 4. 4 times 4 is 16, plus 1, 17. 17, and I still have my pi out front, right?
Yeah.
So now it's going to be pi over 4 out front, and from my integration I am going to have, let's see, let's do the integration of that. U to the 1/2 is going to give me 2u to the 3/2 over
12.
3.
Oh, 3, because, yeah, you're right.
Yeah, I took it out, right?
Yeah.
And that's going to be from 5 to 17. So it's going to be pi over 4 bracket, and that's going to give me u, oh crap, is ugly. So it's going to be 2, 5 to the 3/2 over 3 minus 2 times 17 to 3/2 over 3. So either way, this one getting ugly in here. Okay, so as an exact answer, what could you factor out of this? 2/3, right?
Yeah.
I'm gonna factor out a 2/3, right? So it would be, if I take out a 2/3 from both of these, right? What's gonna happen to my pi over 4? 2 pi over 12, which is just
Oh, pi 6.
pi over 6 times quantity of 5 to the 3/2 minus 17 to the 3/2.
That's about as simple as without.
Yes. That's your non-calculator question. So, what is the hardest part out of all this?
Identifying what to use. Your
Yeah, what to use for the use of.
Yeah.
And it's not always going to be what we've done previously. We have identities. We have, you know what? Got to use some algebra sometimes to actually use this. All right, questions? Are we okay or no?
Wait, I just want to make sure. So the reason you changed the bounds is because if you were to put the u back in, it would be the same thing.
It'll be the same
Yeah.
thing, but yeah.
Okay.
So when you use sub, when you're doing this, you could actually change the bounds. So you sub the bounds also.
Okay.
So otherwise, okay, so when we're done, so once we got to this point, then I would have to put this back in.
Yeah.
So the 4x plus 1 back into this, and then plug it back in. So I would still end up with the same values. The same values, it's just at the end it's going to come out being weird.
Okay.
Okay, it's a little bit simpler, so you don't have to go back to what you use sub.
Okay.
So right here, just to change the bounds, so just put whatever my bounds are into my u, or for my u sub, for my x value, and it's going to give me my u bound. My u bound goes from 1 to 5, and then from 4 to 17. And it saves you a whole lot of work later on. All right, make sense? Okay, so I'm going to give you guys this. All right, I think that one's it. Yeah, summary. So it has your formula here. There we go. All right. Like, share, subscribe.